Take it away.
All right, I need everybody to stand up. No, just kidding. All right, so hi. Hopefully you're here to talk about virtual kubelets or hear somebody talk about it a little bit. I am Brian, CPU Guy 83.
I'm Deep. Nice to meet you all.
So yeah, today we're going to learn about virtual kubelet. We'll go over some basics first, but then we're going to get pretty deep into the code so you can kind of understand why it's useful and how you can actually make use of it. And then hopefully also, if you like it, then you'll be interested in contributing to the project, and we'll talk about that a bit as well.
OK, so we're going to start out by talking a little bit about what a kubelet actually is. Quick show of hands. Do you know what a kubelet is? OK, this is meant to be like a mid-tier talk, so you better know. No, I'm kidding. I'm going to go into it just a little bit so you guys have an understanding of sort of basic understanding that we can build on. So a kubelet is an agent that runs on each node in your cluster. Its responsibility is to make things actually run on that node. And so when you come to your Kubernetes cluster and you want to deploy a pod, the kubelet is the one that's actually responsible for communicating with the container runtime underneath and running that pod for you. So in order to do this, the first thing a kubelet does is it registers a node with your actual API server with your Kubernetes cluster. So we have a kubelet here on a node that's named TARDIS. Reaches out to the server, says, hi, I'm a node. So now when you as a user come to your cluster and want to deploy an actual pod or a set of containers, you come with your pod spec or pod specification. And the scheduler looks around and says, oh, it looks like TARDIS, the node has some space on it. So why don't I schedule this particular pod to TARDIS? So the pod spec is now updated to effectively say that it needs to run on a node named TARDIS. And so in the meanwhile, what's actually happening is your kubelet on that node is consistently watching for pods that are coming in that are apparently supposed to be running on TARDIS. So it sees this new pod specification come in with a new pod that needs to run. And so it picks it up and looks around on the node to say, hey, actually, this pod isn't running yet. And so we need to reconcile the state with what's expected from the user with what's actually happening on the node. So what do? We actually deploy this. So the kubelet communicates with the container runtime underneath, so maybe CRI, and deploys the container. So what's actually happening here is that the kubelet is able to abstract away both the container runtime as well as the concept of the node away from the cluster. So now that you know what a kubelet actually is, Brian, why don't we talk a little bit about a virtual kubelet?
All right, so virtual kubelet. First of all, it is not the kubelet. Like, there's a lot of people ask me, oh, is this part of in-tree, whatever? No, it's not in-tree. It's a totally separate project. Kubelet doesn't use our stuff. We use some stuff from kubelet, but it's not the kubelet. But what we do is take some of the functionality that kubelet is responsible for and kind of make it so you can take that as a library and run with it, so you can abstract away the container runtime and stuff yourself. So what happens? Well, how does that work? Mostly magic, but not really. So just like the kubelet, virtual kubelet comes online. It says, hi, I'm a node.
What's up?
You create a pod. It says, oh, this is supposed to go to virtual kubelet. Let's go ahead and do that. And so virtual kubelet's watching the API server for pods assigned to it. And then it goes ahead and says, oh, I have a pod. I need to go ahead and create that pod. And so, yeah, really quick. That's how kubelet works. That's how virtual kubelet works.
Nice. Virtual kubelet today is a project that does exist on GitHub. You're welcome to go to the link whenever you get a chance. So today we've got 5 core maintainers from Netflix, Microsoft, VMware. The latest release actually shipped 5 days ago. It may or may not have had to do with the demo that we're about to show you. Cannot confirm. There's 6 official providers in the repo itself that are linked to that you can take a look. I'll be talking a little bit more about the providers later on in this conversation. We also have several more unofficial ones. Again, some may or may not have been conceived for the sake of this talk, and some of the demos that we're going to show you, as you'll find out. It's currently a sandbox project. We're working towards getting it incubation. The last time we talked about VK in depth was at KubeCon over the summer at Shanghai. Actually, that's a lie. The last time we talked about VK was yesterday. Thank you to Ria and Sargan for their talk yesterday. But since the summer, a few different things we want to call out. There were 3 major releases. It actually 1.0, that's a pretty big deal because it meant that we stabilized a bunch of the interfaces. The providers moved outside the organization tree and now consume VK as a library. So Brian will talk a little bit more about what it means to consume VK as a library. We had a bunch of bug fixes. We introduced support for graceful pod deletion, et cetera, et cetera. If you want to learn a little bit more about the state of the project, that's something we'd love to discuss with you after this presentation. So I think we should delve a little bit more into the anatomy of the actual virtual kubelet.
Yeah. So what does a virtual kubelet look like? So first, it's a library that you take and import, and you make it do interesting things. Some of the things that it provides are, or the two basic components that it provides are a node controller and a pod controller. I have some pretty words later that you can, if you're looking at the slides later, you can actually see the explanations. But so node controller is responsible for doing the hi, I'm a node, and registering itself and keeping itself kind of in the cluster. Otherwise, if you just register and say bye, then Kubernetes will delete your node, it'll go not ready. So yeah, register as a node. Then you have a pod controller, and the pod controller is responsible for watching for nodes that have been, or watching for pods that have been scheduled to that node, and making sure that, that it's actually running. Those are the green parts. The orange parts are kind of what you provide. So we have a node provider. We kind of just have this default node provider that you can use that doesn't really do anything other than exist, and we take care of the rest. Or you can choose to implement your own, and basically the idea there is if you have a node status update, then you will go ahead and notify the node controller, oh, there's a status update, we need to send this off. But otherwise, we just make sure the status is properly taken care of. It supports node leases, which is an alpha API, as well as just regular node status updates. Likewise, for the pod controller, we have a pod provider. The pod provider is responsible for creating, deleting, updating all the life cycle of an actual pod itself.
So for those of you that weren't paying attention, look at these slides
Yeah.
later.
Yeah, you can look at it later. So with that, I have some code to show.
Can you see this at the back? Thank you.
See a bunch of import statements. So, so we're going to consume Virtual-kubelet as a library to create a thing that will run itself as a node and run pods on a cluster. So what we got here is first I kind of loaded this up to serve so I could pull like debug stats out of it when I was testing stuff. It's nothing. Then we set up logging. We make it so that we can, so everything in Virtual-kubelet kind of depends on a context that you pass into the runtime. When the context is canceled, we quit the runtime. So we want to make sure the runtime shuts down properly when we get kill signals, so we go ahead and set up a context for that. We set up a new Kubernetes client using a passed-in config, kubeconfig file. We pulled a node name off of, because it doesn't matter what the node name is, we just need to specify one. So we pull that out of the environment as well. Now, for the next thing we do is we go ahead and create a pod informer factory. Now, what a pod informer is it's a cache for whatever objects you are wanting to watch. So when things happen, the pod informer is automatically updated, and you end up getting a notification saying that something changed. The cache should generally always be up to date. It's a nice thing you don't have to deal with. The Kubernetes client Go kind of deals with that. The main thing with the pod informer here is we are specifying a specific filter for this, so we are only caching pods that are assigned to our node. Then we go ahead and create the pod informer. And then since we're also interested in other things like secrets, config maps, and services, because pods need those things, and they do things like inject those in through download API and all that fun stuff, we have to pull those in as well. Only we don't care about node name there because that stuff isn't assigned to nodes. We have an event broadcaster because the core runtime does send a couple events, but mostly we expect a provider to make events because it's just, there's more going on inside the provider than in a core runtime. And then we've got some nasty things. So I'm not planning on open sourcing this, I'm sorry, because I don't want anybody to run this ever. It's a security hole, just don't do it. You'll see later. So yeah, some context for that is this is a provider that's going to run on my MacBook Pro, connecting to a cluster in AKS. And what's going to happen is this is going to run container images. I won't call them containers because they're not, but we take the image and execute them. And inside the image is a statically compiled macOS binary.
Well, we promised you deep dive and we promised you ridiculous scenarios, so you're going to get them both.
Yeah, this is horrible. Just don't do this. And to do that, we also use some containerd libraries to help us like fetch images and stuff. It's pretty awesome. We create the pod controller. So the pod controller just needs these clients and pod informers and critically the provider. And likewise, we go ahead and create a node controller. And with that, we also have to create a node spec. So the spec can be literally whatever you need it to be. You can see here I'm grabbing the number of CPUs on the system that, that Go is reporting. And then I just pulled numbers for memory storage and max number of pods that will be scheduled to it. These are just used for kind of soft limits that the kube scheduler uses to not oversubscribe the node. And then we also have to make sure all our conditions are correct. If our conditions aren't ready or whatever, then Kubernetes won't schedule to it. You can, of course, customize this to actually query real things and figure out if these things are actually ready and how much space is available and all that fun stuff. And so we've got a pod informer factory and the other informers that go ahead and need to get started up so that they start syncing pods and all that fun stuff. And then we go ahead and start up the pod controller. So this is actually where the runtime fires up. They're the first half of the runtime. So what's going to happen here is inside this Go routine, we're going to run some reconciliation loops to make sure that our pods that are scheduled are in sync with pods that are actually running or not running. So we wait for the boot up for that to be ready or for things to have gone horribly wrong and canceled out, and we fatal out. Once we know that everything's ready, we go ahead and fire up the node. And at this point, Kubernetes will be able to schedule to our node. And
your Mac.
What's that?
Your Mac.
To my Mac. It's hardly a node. So I will show you that part a little bit later.
Yeah.
I think it's time to talk about what actually is a provider.
Yeah, so let me really quickly define the provider for you, and then we can talk a little bit about what that looks like by turning his Mac effectively into an extension of a cluster. But main things for you to know, number one, it has to provide the plumbing to support the actual pod lifecycle, as well as the supporting resources and whatever infrastructure you choose to extend your Kubernetes cluster with. So in this case, his laptop. But in other cases, whatever infrastructure you so choose to make your deployment more extensible, more flexible within your Kubernetes cluster. There was an interesting way to describe this I heard yesterday from Sargon that I really liked, was that you're effectively transforming a declarative model in your Kubernetes cluster into an imperative one that is now flexible to whatever infrastructure you're actually choosing to deploy things into. So your VK becomes a way in which you take your Kubernetes cluster and effectively you can do anything with it. It turns it into just the control plane where now you have a fully flexible data plane. Of course, that also means it must conform to the current Virtual-kubelet API surface and also needs to use a well-defined set of callbacks to get status as well as data across the board to the Kubernetes cluster, because we don't want direct access to the API server from wherever that infrastructure is actually running. Why don't you actually show them how that code runs, now that you've taken us so far into it?
Sure. So first I'll go over the provider interface here. These are just basic create, delete things. So when Virtual-kubelet sees that a pod is created or deleted, we just go ahead and call this. We'll do some extra things like fill in some downward API things. But for the most part, we're just determining, is this an update or is this a create, and figuring out how to distribute that out. And with that, I will go ahead and demo Basura to you, which is the name of the demo, which is Spanish for trash. So literally, don't do this. All right. Let me make sure nothing is running. Oh, I already had stuff running, sorry. Font size, thank you.
Is that big enough?
Good?
This is more or less.
More? There we go. All right, so okay, get nodes. I've got nothing. So let's go ahead and fire this bad boy up. And there we go. Our thing is ready. I don't remember if I deleted the pod. Good, I did. So first thing we can do, you can see I gave it the name Darwin test, gave it a custom version here. I guess I need more size. There we go.
Make it bigger, even more
Make
bigger.
it bigger. Better? Awesome. Whoop. MacBook keyboards, love them. Okay, so.
They're basura.
Yes. All right, so you can see I've got a couple of things here. So one of the things that happened is Kubernetes tried to schedule a bunch of stuff to us because I didn't set things up as expected. So it tried to set up kube routes on the node that doesn't exist. So all that stuff failed, but that's fine.
That's why you're not supposed to do this at home.
Yeah. Operating system, Darwin, all that fun stuff. All right, so I have this pod. You can run this, it's fine. It's just a HTTP server that says hello. But it's compiled for Mac, though. It's going to be running directly on my Mac. So just to prove, there is no demo thing running except for the fact that I'm in the demos folder. So there we go. And pretty quickly it was running because I already had the images fetched. So there we go. And there we have demo running. Let's. Uh-oh. There we go. Hello. It says hello.
I think you
for
need to
everybody
zoom
who
in.
can't
They
see
won't
it.
believe you at the back. There you go.
It says hello. So you can see we have this running. It looks just like a regular node, or a regular pod, rather. I can do things like, I can manually terminate it. I can delete it from Kubernetes and it'll get terminated, or I can just go ahead and kill 87873. And with that, we should be getting some, so we'll see some logs here that some stuff happened. Container exited. And we should see, okay, sweet, we got exit codes -1. And that's actually nice. Some things you can customize is kind of these status messages or whatever. You should use official ones, but this was nice to actually get in to see for testing. All right, so we can see that everything is shut down. Well, it says failed because I killed it and it did a non-zero exit, but that's fine. And I can go ahead and delete the pod. And we should see a deletion event, sync handled. And there we go. And you can see the node status being updated as well. So what did we see here? We saw my Mac running as a node in a cluster for AKS, which is running in Azure, executing random crap that isn't an image. And you can kind of see what does a Mac container look like? Yeah, there we go. Originally, I was going to use a chroot, but apparently you can't chroot with a unprivileged user. And by the way, this is running on privilege, which is kind of cool. So I got rid of the chroot and added a dot to the front of the command to execute it in the proper. So we changed the directory and then just make sure it's not executing slash. It's doing dot, so it's local. So yeah, that is my crappy container runtime. One of the things here is notifying of pod status updates. So we kind of have two modes of operating. So we have async and non-async. So non-async is kind of the old way. I wish we didn't put it in 1.0, but we did. What happens in this case is we kind of see that you're not an async provider, and we just kind of run this loop that asks every 5 seconds, what pods do you have? What are the statuses of the pods? And we have to go and determine if you need a pod status update. And it's not bad for just a couple of pods, but when you have 100 pods, that's really terrible. So we changed over to have this async notification model where we tell the provider, hey, when you get a pod status update, call this function. And so that's what we're doing here. We make a copy of our internal pod state and send that up to Virtual-kubelet. And when it receives that, it sends the status update to Kubernetes. So inside here, we actually don't have any, there's no Kubernetes client or anything like that. The provider just has a bunch of pod states, content store for, this is for storing images from that we pull, and the notify function that gets passed down on startup, and some basic pod state. So yeah, in general, it's relatively easy to destroy my laptop. So yeah, and with that,
I think we should talk about some more useful providers.
yes, I think more useful would be better.
Or just not breaking your laptop.
Yeah.
Whatever it is, really. So why should you build a provider, right? So number one, main thing we like to talk about is that it gives you this abstraction away from the concept of a node that you're used to, so you can now extend this cluster to run anywhere. So here we ran it on a Mac. We have a lot of customers that try a whole bunch of more interesting things. For those of you that were at Sargon's talk yesterday, you heard about how they use it at Netflix with their infrastructure called Titus. But the idea is you can take this Kubernetes cluster, use it as your surface or your control plane for deploying applications to your infrastructure, which could be nodes that are in VMs and wherever you're running your Kubernetes cluster, or it could be anything else. It could be his Mac. Would not recommend. But yeah, so that's the main thing. Other than that, it gives you, with those infrastructures, a way to have more granular resource consumption. So for example, one of the products we have in Azure is called Azure Container Instances. So the purpose behind Azure Container Instances, or ACI, is effectively to deploy pods on demand, or just container images on demand. And when you deploy those pods, you're only consuming the resources required for that pod specifically. So you define how many cores you need and how much memory you need for that pod, and that's the resource you consume, that's the resource you pay for, which now means if you've got a Kubernetes cluster running and you want to spin up pods on demand, but you don't want to pay for an entire VM in Azure or pay for setting up a server, or you want to buy Brian's Mac off of him, whatever, you have that set of options, or you could just go and deploy a pod and just pay for the resources that you need for that. It also unlocks a bunch of hybrid scenarios. So we've got people using this where clusters are either running in the cloud or on premises and are extending in one way or another if you can get the networking right. It also allows you to then have a bunch of HA deployments. It allows you to deploy things on the edge. So with really, really small machines, you can start scheduling containers onto them because you can use VK as your interface to do that. And also, last but I guess not necessarily least, it is an alternative to the notion of a kubelet. And so if you were to use it in place of a kubelet for whatever reason, that does exist. A couple of gotchas that are worth discussing. So networking is super hard when it comes to some of these things. So sharing a network configuration from a Kubernetes cluster onto whatever flexible infrastructure you're going to isn't necessarily trivial. Additionally, in the case of private networking or setting up a kube proxy or whatever service mesh you choose to use or L7 routing you want to set up across those different places, not necessarily the most trivial, but certainly achievable. One question that came up a lot when we were building the provider for ACI was, what's the max node resource? Do we just set it at infinite because you could just deploy as many as you want? Then what stops the scheduler from putting everything onto ACI? Then what's the point of having your worker nodes? Like, all of these things sort of come into play where you have to be a little bit more deliberate about how you're actually placing things inside the cluster and educate your cluster to do the things in a way that you expect it to, as opposed to be caught off guard. And so we settled on setting like thousands of cores and like some terabyte memory effectively, and then using taints and tolerances within all AKS clusters, so that's Azure Kubernetes Service clusters, to not automatically put everything onto ACI, but instead deploy mostly to worker nodes if available, and then deliberately deploy out to ACI when needed. Other than that, versioning, you now have a Virtual-kubelet version as well as a Kubernetes version. We've figured out some ways around that. Happy to take feedback if you've got better suggestions on that. Monitoring pods as well. So a lot of people look to VK as a way of dynamic scaling for pods. Again, typically you've got like a daemon set or you've got an agent that's running on your host that's gathering that data for all of those pods, reporting it back to the control plane or the HPA that's helping you scale these pods out. But if you move to more flexible infrastructures, you may not have the notion of something that can run on the host. And we don't support the notion of a daemon set in Virtual-kubelet because it's effectively like infinite nodes that are actually backing up like this single node sort of concept or node extension in your cluster. So You have to do some tricks there as well. We currently try to come as close as we can to node aggregation, so we aggregate all the metrics of the containers coming through that particular VK instance and aggregate them and send them back to the control plane. Still stuff we're looking to improve and figure out on. So we've got a pretty good set of providers so far, so some familiar names and logos up here. You can take a look at these more in depth on our GitHub page. But yeah, I'm going to show you guys a little bit more on the ACI side of things. So that's the Azure ACI connector that we have, or the provider that we have. To set the stage for that, sort of, just so you're aware, the idea is that, as I was describing, you sort of have pods on demand. So your VK instance at your cluster, or we even have an add-on to AKS clusters called virtual nodes that you can just sort of add an extension. But the idea is we leverage the technology behind Virtual-kubelet to say, instead of deploying to VMs, deploy to this flexible infrastructure that can just deploy pods on demand. And typically, when we demo this particular provider, we look at it for burst, because that's the scenario in which we see most of our customers using it today, which is, hey, I don't have time to spin up VMs, or I only need these pods to run for X amount of time, and I don't need them to run for longer. It doesn't make sense for me to provision out a bunch of VMs and scale them back down. I want something more flexible, so I'm just going to deploy pods. But today I'm going to do something a little bit different, and so I'm going to switch to hopefully this works.
Yep.
Yes, OK. So apparently nobody's gotten this thing to work all day, but I prayed to the demo gods for like 4 hours. And so I think things should be good. So I'm in, ooh. OK, somebody was complaining about this yesterday. Joey, where are you? It's K now. So I'm inside my Kubernetes cluster. You can see there's a bunch of pods that are currently running. So these actually map to virtual kubelets that are identified for specific regions. So you see Australia East, East US, Japan East, North Europe, and West US. And what I've effectively done is we just set up virtual kubelets that are pointed to different geographic regions and can deploy onto ACI into those regions. I've got this really cool front end. I don't want you to think of this as an end solution. I want this more to sort of spark your thoughts when it comes to how can I use Kubernetes or Virtual-kubelet to have geo-distributed deployments, deployments on demand in different parts of the world, just have an extensible sort of backend, not be limited by the fact that everything needs to run in one place, whether that's for security reasons or networking reasons or infrastructure availability. But yeah, so I've got these regions. This map sort of zooms out, and you can see all the places where I've got these little hotspots, and currently nothing's deployed. For those of you that are in the room and are smarter than I am, you've also looked at the top of the browser, seen that this endpoint is not secure. You're welcome to go to it if you want and start pressing these buttons. But the idea is effectively that I'm going to do this in a more programmatic way. If you actually do this yourself, you're probably going to do this in an automated way where you look at incoming requests, and you can trigger them using taints and tolerances to actually go somewhere. I see somebody entering the IP address. Nice. But I'm effectively just going to do a few, and you're going to see, and then I'll scale up a bunch more. But I'm going to start out with one in just West US. So effectively, what should happen is you should see a deployment starting. You see geodemo West US, so that's VK starting to spin up an ACI deployment in that particular region. I should have also shown you this. You can see that the virtual nodes is set up for each of these regions. And the way sort of Azure does things with a Kubernetes cluster is you have this like hidden resource group that actually contains all the things that are required for Kubernetes to run. In this resource group, in a couple of seconds, you'll actually see the ACI resource pop up. Boom, OK, somebody else clicked West US as well. It wasn't just me. And if we go to the UI, you'll start to see that these are still popping up. And I'm just going to go ham on this for a few seconds. If anybody has regions they like, scream. OK, nobody has regions they like. You are all sad. OK, I just did a bunch. Let's see what. OK, yeah, lots coming. And yeah, so if I click into this, like very soon you'll start to see, OK, so 4 in East US have already come up. The one in North Europe's already up. Somebody yelled Australia. The Australia one's already up. And there's a bunch on the way. So as I continue to click on these, that number used to be 2. It's now 5. This number used to be 4, I think. Now it's 8. So yeah, you can start to see that they're scaling up ridiculously quickly. That's because that's what ACI is specialized for. And so you're able to leverage that inside of your Kubernetes cluster without necessarily extending everywhere. And now in that backing resource group, you can see here are the ones that are deployed in Australia, lots in Australia, some in East US, Japan, et cetera. But yeah, so I want your takeaway from this to be like not that you should think of VK necessarily as just replacing the notion of a node, but also think about like what it can do for you in terms of leveling up your understanding of your Kubernetes cluster and your use of the Kubernetes cluster to become a more flexible control plane, a more flexible API server that can then deploy things to any place you need them to be in any infrastructure that you want them to be in, and use this as a tool to enable workloads, whether they're serverless or on-premises or anywhere, in a way that solves the problems that you actually have in delivering production scale, production grade workloads for your company, for yourselves, for your customers, and generate the business value there. Awesome. I'm going to switch back to the slides. Nice. Want to talk a little bit about the roadmap?
Yeah, sure. So these are things that some of them we're working on, some of them we would like to work on. Custom pod GC policies. This is like when a pod has been deleted, when someone calls delete pod, what do we actually do? And can we inject custom behavior into do interesting things? Metrics. So these would be metrics. So we already have metrics for pods. So they hook into Heapster or metric server or whatever. But these would be metrics for the runtime itself. So like if you get an error on a create pod, we would be able to report some metric that something happened, that kind of stuff. One thing, building a few providers now, I've noticed is there's a lot of shared code in between providers, or at least shared concepts. So building some sort of helpers for actually building a provider, so you don't have to do a lot of rigorous code to do things like, how do you turn a pod into a bunch of containers with the right settings and crazy stuff like that. The other thing is a little bit more crazy, but maybe not, is kind of a runtime-less model where instead of you spinning up a runtime, you create the runtime. So we provide all the helpers, and you run the for loops. And basically enabling us to allow you to inject whatever behavior you need to, rather than have to have specific extension points. Yeah, so if we're missing something that you're using VK, we're missing something, let us know. If you think some idea is awesome that you don't see here, let us know. Especially bring it up on the community sync or open an issue. Yeah.
Cool. We have about 2 minutes left. Do you still want to show the tracing one?
2 minutes, huh?
What do you think?
Probably not. Maybe
okay,
questions.
Probably not. All right, cool. Well,
by the way, we support tracing with OpenSysIS or Open Tracing, whatever, inside the runtime as well. So I was going to show you a Jaeger graph of awesome stuff, but yeah.
I did want to say that somebody definitely hopped on this and helped me, because I just ended up deleting 160 instances, and I definitely didn't click 160 times. But it is pretty cool that we were able to schedule across all those regions in like the 3-4 minutes that we've been watching. But anyway, so we're about to wrap up. Main things to God, again, that's the GitHub repo. Go check it out. Go help us contribute. There's a Slack channel that you should join. We have community meetings every other week on Wednesdays at 11 a.m. Pacific. So you're welcome to join those as well. And with that, any questions? No questions. Oh, some questions. We need a mic, actually. That's good.
I can repeat the question.
Back?
What was the question?
For the example of launching public cloud instances to temporarily extend a cluster, you mentioned that the networking part would be hard. And I'm interested in any further kind of pointers or advice you have about that part of the problem.
Sure. So the question was, just for everybody listening on the line and everything, we mentioned the networking can be hard, particularly in the cloud, and extending that to like in Azure VNets and all that kind of stuff. I'm interested in more in how to tackle that. So I'll leave that to Deep.
Yeah, sure. So we had to do some of this for the ACI provider specifically as well. And so part of it is that when you deploy resources in a different infrastructure, they come with different networking settings that don't always map back to what you have set up in your Kubernetes cluster. It may mean that it's coming up in a different VNet, and now you need to find a way in which you can actually communicate over private internet across those two VNets. So in Azure, we have a technology called VNet peering that enables us to do this. Other things that you can do is actually introduce a new subnet and make sure wherever your infrastructure is running is actually part of the same VNet and is just deployed in a different subnet. With the right IP spacing, you can also solve for that. The other thing we wanted to do is make sure we had kubeproxy compatibility. And so we actually deploy something alongside the pod in ACI now when it's coming through VK that actually sets up like route tables with the use of a IP route table file. And we literally use that to make sure that the mapping is correct. So whatever consistency you expected from when you deployed a service into the Kubernetes cluster, you'd get the same thing even if the pod spun up in ACI through Virtual-kubelet in terms of your DNS and your kube proxy expectations for communication across those containers. And so we had to do some hacks to effectively make sure that the networking config does stretch over into that whatever foreign infrastructure it may be. It might be that the infrastructure you choose may not support those things. And it's kind of, the caveat is there to ensure that you think about these things because it's going to be one of the big problems you run into if you haven't. And so I just want to make sure that that's a deliberate thought. It's part of your planning process, and you ensure that you've got a path for the things you actually need. You don't have to solve all the cases. Like a lot of VK implementations don't necessarily do every single thing a regular kubelet does, and that's fine. It's meant to be an extensible tool that you use to solve your problem as opposed to catch-all #1 extension to Kubernetes.
With that, I think we probably are.
We got one at the back. Do we have time?
Yeah.
I think we can take one and then.
Yeah, okay.
Excuse me. Is there any intention?
Oh, Mike.
I don't have to shout.
It's like you scream font, we're screaming mic. Ha.
I won't scream into the mic. Is there any intention to upstream this in any way? And if you look at what a real kubelet is, it's a battle tested virtual kubelet with a provider for Linux, essentially. The core kube is moving that direction largely, right? Controller managers have become virtual CCMs with a provider, storage. Any intention to do that here too?
So we've definitely brought this up to Signode and what have you, and at least even pulling it into the Kubernetes project, and there's things to kind of work out there, and certainly one of the things that we really need to do is get a real node implementation. Like I have CRI containerd available, but it's not done. And run that through node conformance and that kind of stuff to kind of prove out the runtime to make sure it's solid in terms of could the kubelet import VK instead of some of the stuff that they've been hacking on. I don't know if it even makes sense to do that, but yeah. There's certainly nothing preventing that outside of technical discussions and non-technical discussions and just making things happen.
Cool, I think with that, we'll take a close. I've got a bunch of stickers here, thanks to Ria, who's sitting at the back. If you'd like a Virtual Kubelet sticker, please come up and grab one for me. If you have any additional questions, please come up and see us. We'll be here for a while. Thank you so much for coming.
Thanks.